Hey everyone, I'm Olivia Radcliffe, Marketing and Technical Services Specialist at eBeam Services, and I am here with Dr. Gustavo Varca. Gustavo, you want to give your intro?
Hello, everybody. I am Dr. Varca, also known as Dr. V, and I'm here to answer a couple of questions. I am the new applications manager here at eBeam Services, and I'll be happy to talk to you guys about a little bit of the rocket science we do here.
Rocket science, yeah. So we've been doing this thing where we've been getting questions in as the tech services team have a lot of different questions from different customers. And so Gustavo has graciously agreed to jump on and try to tackle some of these questions that we're getting more frequently than others. Right now, Gustavo, we have been getting a lot of questions about cross-linking hydrogels as well as sterilizing hydrogels. So if it's okay with you, I kind of want to break those into two separate subjects. And if you want to talk a little bit about cross-linking hydrogels, why would we do that? You know, a little bit about the process and maybe some real-world applications.
All right, hydrogels, that's one of my favorite topics.
Good.
So hydrogels are what we call polymeric networks that have the ability of holding a lot amounts of water, right? So you have like a volleyball net based of a polymer that is able to hold water in its internal spaces, right? But you may be wondering, what's the difference that from a regular gel? So regular gel, they're a type of what we call a semi-solid pharmaceutical formulation or pharmaceutical compound, pharmaceutical form that refers to a gel-like structure. It's not solid, it's high liquid content, but it also doesn't behave like a liquid. But those gels, like hair gel, they're based on physical forces, on physical, like proximity fields and all those types of forces. So if you leave them exposed to air, you will end up with just a little bit of powder because they're not chemically bound most of the time. When we talk about hydrogels, and especially radiation cross-linked hydrogels, we are talking about building a chemical structure. Sometimes there are multiple features that you can build, interpenetrating, that could be a variety of it. But in essence, what we're doing is we're creating internal bridges, we're creating cross-links between polymer structure. And that way we can entrap high water content and preserve it there. So that's what the idea of a hydrogel. So that's a chemical cross-linking. If you leave it exposed to air, you end up having a solid piece of polymer. So it's not going to be a powder because it has a solid structure. And that's pretty much used for for pharmaceutical applications, such as wound dressings, but also for the delivery of drugs. You can create advanced delivery systems and benefit of this mechanism of drug release from that. In the cosmetic field, you can use it to deliver active ingredients, to your skin. You can use intradermal hydrogels. You can use, there's a variety of possibilities. And the beauty of using radiation for that is that radiation leaves no residues. It can be cross-linked in the final packaging. And so you don't have to washing steps to remove residual monomers or residual chemicals that you may use to cross-link if you decide to pursue a chemical cross-linking pathway.
So what's actually happening during the cross-linking process?
So you have the formation of new chemical bondages, new chemical bonds within the structure. And that, interestingly, that usually happens in the amorphous structure or semi-crystalline structure. And it's a good example because the crystalline regions of the polymer, they're too well structured. So they're so well structured that it's pretty hard to break that equilibrium and induce new linkages, while the semi-crystalline or the amorphous areas enable more of a change because they're so not organized So that's a good way of understanding crystallinity levels, is the level of organizations of the structure. So the crosslink, we deliver high energy to the amorphous and specifically, right, to the amorphous or semi-crystalline regions. We force them to recombine, and we built linkages that were not there before. And that linkages would trigger what we call cross-linking. The more we cross-link, the stronger they get, the more intense the mechanical properties in most cases. Of course, it all to an extent, because if you use too much dose, you start degrading it, and then you lose the properties. But you can create, as typically, if you're talking about polyvinyl alcohol gel, hydrogels, like I used in my PhD thesis, it goes up and you get a solid and more strong structure, but at some point it melts down, and you know that transition is taking place.
So how do you determine what that dose is, where it starts dropping off?
So you really got to take a look at the polymer structure, and you got to start doing some tests. You got to see how much, it depends on the polymer concentration that you have, because the chains need to be closer to one another enough for this structure to be formed. Otherwise, you end up promoting degradation reactions, chain scissioning. People always believe that you have one phenomena. You never do. You always have chain scission. You always have cross-linking reactions. So it is a balance that we're able to bring by tuning the dose. I don't want to move to the next question, but you got to really base the dose on the polymer itself. But depends if you're looking for sterilization as well, because then there's something very elegant that I like to talk about when it comes to radiation, cross-linking, and sterilization of hydrogels.
That's a very good transition. Okay, talk a little bit about sterilizing hydrogels. Same questions. What is it? Why would we do it?
So what we try to achieve is make sure the product has a low microbial content enough to be used in a biological system, a human being, an animal, so that it will not induce or trigger reactions, right? It will not contaminate the individual. So sterilization of hydrogels, you can be typically, if you have a cross-linked hydrogel, like a chemical cross-linked hydrogel, you could expose it to radiation at specific doses for sterilization purposes only, right? But the ability, and this really makes my eyes shine a little bit, because that's how I got so much interested in radiation, to be honest with you, is because radiation allows us to simultaneously combine, for some polymers, sterilization and cross-linking using one dose. So for a multitude of polymers, and I can name a few, PVP, polyvinyl pyrrolidone, polyvinyl alcohol, we are able to bring enough cross-linking levels to form a hydrogel at the same dose we apply for sterilization. So if we can process it in its final package, so using the same dose, we promote simultaneous cross-linking and sterilization without toxic residues, compounds. It's ready to be used, and that's something I find pretty elegant of the technology.
Elegant. I think that's a very good word to describe it. Not something we would typically use to describe e-beam, but I think that works very well. Well done. So from a practical standpoint, someone has a hydrogel, they want to sterilize, they want to cross-link. They have no idea where to get started. What do they do? Go from there.
Well, they have to find, so here's the thing, if they are in the build, if they have the formulation and they want to pursue a cross-linking, radiation cross-linking path, they can reach out to us if they want, but ideally they have to find a company that is able to sterilize their product and provide the services. Mm-hmm. But we would need to start with some breaking the ground and delivering some dose to the product, because we want to make sure we need to tune the dose towards promoting the sterilization level, but also keeping the cross-linking level to where they desire, because you can end up with a very strong network that is not what they desire, and they may lose the property that they were looking after. So there's got to be some experimental background. I hope I'm not sounding like it's really complicated. It is not simple to do, but it's not impossible. And as I said, we can help customers get there pretty in a pretty fast way. So you got to do a couple material tests. You got to have the bioburden levels understood on your product so we can find a couple of doses to start to work. And of course, there's got to be an engagement between the manufacturer of the product and us so that we can understand where their needs are and tune the dose towards the final application.
So it's that fine balance of finding that dose range between the minimum needed to achieve sterility and the maximum that would then cause degradation if we exceeded it.
Because sometimes you can't. So we need to apply some tricks, and that's the time where you tell me to stop because I'm telling more than I should. There are a couple of tricks that we can do to lower the effects of radiation on the polymer while preserving the effects of our microorganisms.
Okay.
So if we have a highly sensitive product to radiation, there are ways we can overcome the detrimental effects of radiation on the polymer network while preserving the sterility, sterilization ability of the electrons that we're delivering.
Okay.
High energy electrons.
High energy.
More elegant.
Okay, last question. Let's talk about packaging a little bit then for hydrogels for routine sterilization, let's say.
Yes, look, I keep getting surprised as I work more in the e-beam world. I keep getting surprised at the flexibility of packaging that e-beam actually allows. I've learned the opposite for many years, and I'm always being surprised by how customers are being creative in the way they package. So, of course, we need to understand the density to make sure we are delivering the dose properly, but there are ways we can do to present the units to the beam individually while still in a case configuration. Mm-hmm. So we can keep them, we can have multiple rolls, preferably not multiple layers, but we can deliver the dose to multiple products at once in a case configuration. We just gotta, as we just spoke, Olivia, we gotta make sure we tune the dose properly so we can keep the minimum max dose balance within what the range we desire. Because what can happen if you don't do that properly, you may have part of your package half cross-linked and the other part a lot more intensely cross-linked. So in order to keep the dose distribution and the cross-linking levels homogeneous, there's got to be work there. And we're here to help.
We're here to help. All right. We can end on that phrase. We're here to help. All right. Well, thank you. That was very helpful. I think I helped. If anyone has any additional questions about cross-linking or sterilizing hydrogels or anything else, you can reach out to us at ebeam@ebeamservices.com, or I'll stick a link below the video that has a form you can fill out to submit your questions. Any last comments, Gustavo, before we sign off?
Oh, hope I see you guys again soon.
All right. Thank you. Bye, guys.
Bye.